Hi, my name is Rahul Chauhan and I'll be presenting my final project on decoy routing with email as a covert channel for course Computer Networks under Dr. Flavio Esposito. The motivation behind building or implementing this decoy routing is that there are a few countries where common websites like Google, YouTube, Facebook are blocked. For example, China. We all know about the Great Firewall of China. China doesn't allow people to connect to these websites. So people use tools and proxies like OpenVPN, Tor bridges or obfuscation protocol to connect to these websites. But these websites are hosted outside China. They require a server and all the servers are outside China. The government uses deep inspection protocol to block these proxies. So the solution to this is decoy routing. It can be implemented within China itself and using routers. So what exactly is decoy routing? Decoy routing is a new approach to internet censorship circumvention in which routers act as proxy servers. So there is a client who wants to connect to a block site. He sends requests a special packet through a covert channel to the decoy router. Decoy router knows how to decrypt the package and verifies whether the client is a normal client who wants to connect to normal websites or he wants to connect to a censored or a blocked website. If, a, if the parameters match, the decoy router allows user to connect to a censored website, and in real world scenario it would look like that a client is connected to a decoy host, not the blocked host. Now we'll talk about the implementation of the decoy routing. There are a number of ways in which decoy routing can be implemented, but I chose to implement it using email as a covert channel. In the next slide, I'll explain why I used email as a covert channel. So you can see that there are 6 components: client, switch, controller, secret proxy, over destination, and the covert destination. Covert destination is the place which is blocked and user wants to access. So the very first thing is that the client should know controller's email address. So controller is the one where all the routers are being managed. The routers, the decoy routers. So client should know the controller's email ID and also the public key of the controller. Now in the email there are 5 components that are being sent. The first one is a special word, or you can say a magic word, that is just for this particular decoy routing protocol. It's unique to this one, so I named it as decoy RKC. The second is the initial sequence number. Next one is over destination. IP is the current IP of the client, and GX. So we know GX is Diffie-Hellman's exponent, public exponent. X is a private number to the client and GX is a public exponent for Diffie-Hellman. So all the data is being encrypted using public key of the controller and sent via email to the controller. Once the controller identifies that the email and decrypts it with its private key, the flow is added, flow is added to the switch, and a TCP handshake is being done. In the first TCP handshake, the sequence number is same as the initial sequence number. Once the controller verifies that it's same as what was sent in the email, now the decoy router is confirmed. The very next stage is the TLS connection phase. Now to make it look like a normal connection, the TLS connection occurs with the over destination. In the very same time, the first TLS packet is sent to the controller. Now the controller knows that this client wants to initiate a decoy routing. So the controller adds a rule in the switch so that in future connections all the requests are redirected to a secret proxy, and also it sends the TLS packet with the public Diffie-Hellman exponent, right? The very same time it sends a TCP spoof, that is a TCP packet to the over destination to make it feel that the connection that is set up is a real one and it goes to the over destination. Now
the secret proxy sends the Diffie-Hellman with the HMAC. Now the Diffie-Hellman this key is generated using a private Diffie-Hellman number that is for secret proxy, that is Y, and GX is already sent to the secret proxy using client. And this NS is a nonce which looks like a random bit to a sensor, but it will help to verify that that it is the secret proxy who sent. Now the client verifies that it's the secret proxy which sends the data to the client. Now the client initiates the next TLS data using a nonce and the derived GXY key. So it derives using its own key, own number, that is X, and the GY is public exponent that was being sent using secret proxy. Now these two stages are the stage where it confirms that the decoy routing setup is done, and the clients all requests through the secret proxy will be sent to the covert destination.
Why email as a covert channel? So it's easier to implement both the web version and the terminal version. Terminal version uses SMTP for Mininet to conduct experiments. It's less suspicious, less likely to get caught by the sensors. If get caught, we can use steganography to hide the data in form of image, videos, or messages. I did a comparison between wget results in decoy RKC, that is the covert channel, and normal wget. The results were quite similar, not much difference. Now we'll see the working. This is the working of how I implemented everything. We'll start the controller first. After the switch is initialized, we can start the proxy, and here we'll start the main client. So the client has everything. So it has, this is the over destination and this is the covert destination. Just 1 second. Yeah, and this is the hard timeout. So if it is not able to connect within this time limit 30 seconds, it will automatically close. So this is the place I told you that it connect. This is the magic keyword, and this is the IP, local IP, and this is where it wants to connect. It's sending an email as a covert to the to verify to the controller. It automates everything with the help of Selenium. If we don't want the web part, we can use, I used the web mail. If we want, I conducted the tests using Mininet, where I used SMTP, so it does everything using terminal itself. So I wanted to show this, that how it does it encrypts everything inside the message, and the controller is now try to decrypt the message. Now it's sort of, I think, decrypted the message. These are all the yeah, it's pretty much done. So what it does is, last thing is total bytes down. So I download the file of the index, the web page, just to see the performance between a normal wget connection and a wget connection using decoy routing.